In this video, we are going to be learning about friction forces. Now, friction is the force that tries to get something to stop moving. So if you take your hand and you rub it against the table, it's that force that's pushing back on your hand that slows it down and tries to stop it from sliding across the table. So, just some things to note about friction is that the friction force always acts in the opposite direction of the movement. The equation for friction is equal to the coefficient of friction times the normal force. Now, the normal force is the force that acts perpendicular to the surface and towards the object. For example, if we have some sort of box sitting on a countertop, if we just look at this box alone over here, there's going to be a force exerted on the box from the table that holds the box in place. Otherwise, the box would just fall through the table. The table's pushing up onto the box to keep it up, and it's holding it up. And that's that normal force. And again, it's always acting in the perpendicular direction of that surface. So that surface is horizontal. So our normal force is going to be vertical. Let's go ahead and look at an example of a friction problem. Again, let's just say we have some sort of box sitting on the floor. And let's say the weight of this box is 100 pounds. Let's say the coefficient of friction is equal to 0.2. Say the height of this box is 5 feet. The width, let's just say it's 4 feet. And the force P being exerted on this box is going to be at a height 2.5 feet. So, looking at this, we want to find the maximum force that can be applied without moving the box. So the first thing we want to be able to recognize when looking at a friction problem is identify all the different scenarios in which this box could move. So in this case, when we push on this box is either going to just slide across the floor, or pushing here is going to cause the box to tip about that point there. So in this case, we have two scenarios. The first being sliding, and the second being tipping. So we're going to evaluate both of these scenarios and then compare our forces, and whichever force is less, that's the controlling scenario. So let's go ahead and look at sliding. First, we're always going to start with a free body diagram. So with a free body diagram, you always start with your object. Then you apply your forces. The weight of the box is going to act through its center of gravity, 100 pounds. So it's going to align with this. It's going to be halfway from the top to the bottom. And it's going to be halfway for the width as well. And now for sliding, we're going to apply our normal force, which is going to act through the center of gravity for sliding, and then our friction force, which acts along the bottom of the box, again, opposite of the direction of movement. So if we're pushing on the box to the right, friction is going to be pushing back against it to try to stop it from moving. So again, our friction force is acting that way. All right, once we have our free body diagram complete, we can use our sum of forces to figure out our P. So we'll start sum of forces y equals 0. Choose a direction to be positive. We're going to get n minus 100 pounds equals 0, so n equals 100 pounds. Sum of forces x equals 0. Choose a direction to be positive. And we're going to get P minus F equals 0. But we know from above that F equals coefficient of friction times the normal force. So we can go ahead and substitute this into our equation. So P minus mu times N equals 0. We know mu and we know N, so we can go ahead and plug those in. 0.2 times 100 pounds equals 0. And we can solve for P. So P equals 20 pounds. So now we have our P slide, which is going to be 20 pounds. So what this means is that you will need to push on this box with 20 pounds of force in order to get it to slide. Now, the reason that I did sum of forces y first is because I knew I was going to need this normal force in our sum of forces x. However, if you did do sum of forces x first, you'll be left with two unknowns, and then you can just do your sum of forces y get that unknown, and then plug it back into this equation. Either way, it's going to get you the right answer. It takes a little bit longer if you do sum of forces x first, but if you can't recognize which one to do first, just start somewhere and you'll work your way out and you'll figure out P in the end. And that's okay. Just start somewhere. Don't get too caught up in not knowing where to start that you don't start at all. Just start somewhere, and usually you'll be able to work yourself through the problem to where you can figure it out. All right, so we've checked that scenario. So now let's check the tipping scenario. Again, we're going to start by drawing our free body diagram. So start by drawing the object. Apply your forces. And then apply your friction forces. So when we're tipping, we know that we're going to tip about this point here. We'll label that point O. And since when this box is tipped, this is going to be the only point that's touching your surface. So your normal force and your friction force are going to act at that point. Again, we'll just add these dimensions here. All right, and now when you're checking tipping, since it's a rotation type of movement, we're going to use our sum of moments equation. And I'm going to take it about that point that it's tipping, choose a direction, and then we'll write our equation. So we'll have P times 2.5 feet minus 100 times 2 feet equals 0. And you can solve for P, and I calculate 80 pounds. So P tip equals 80 pounds. So what this means is that in order to get this box to tip, it's going to take 80 pounds. So in comparing our P slide and our P tip, we know that it takes less force for it to slide than it does to tip. So therefore, sliding controls and our P max is going to be 20 pounds. Now, if you're having trouble visualizing or understanding why we picked the smaller P, just think about adding P in increments of 5 pounds. So you push on it with 5 pounds, nothing happens. Push on the box with 10 pounds, again, nothing happens. Push on it with 15 pounds, nothing happens. But as soon as you push on it with 20 pounds, it starts to slide. You keep adding weight and it's just going to continue to slide faster. So therefore, we never even have the opportunity for the box to tip. So whichever movement you reach first when you're adding increments of pounds, that's going to be the one that controls, because that movement is going to happen first. So therefore, our maximum amount of force that can be applied without movement is going to be 20 pounds. If you have any questions about this example or other friction examples, you can head over to our homework help page or a tutoring page where you can get specialized help with your specific questions. Also, feel free to contact us. by sending us an email to taylorstutoring, etc. @gmail.com, or you can use the chat function below.